Now, hello everyone. Here is another concept in chemistry that I want to share with you. So let's look at it together. We have a balancing of chemical equation. In this case, for us to have a chemical equation, you must have a reactant and you must also have the product. Now, here now, you have the reactant to be aluminium tetraoxosulfate 6 reacting with calcium 2 bromide to produce what is called to produce what we call calcium tetraoxosulfate 6 plus what plus aluminium 3 bromide. So that is the product. For us now to have a balanced equation, you must consider what are the elements involved in the reactant and what are the elements involved in the product. Of course, it must be the same. Now, we are having how many aluminium here? We are having two atoms of aluminium. How many sulfur do you have here? We are having three sulfur, atoms of sulfur. Why that of oxygen here? That is 2 multiplied by 3. 4 multiplied by 3. That is 12 atoms. Then in calcium now, here, we are having 1 atoms. In bromine here, bromine atoms here is 2. Why in the other side, which is the product, we are having how many aluminium? 1. That of sulfur is also 1. Oxygen here is 4. And that of calcium is 1. And the bromine atom here is 3. So when you look at it, you compare the atoms of element involved in the reactant and the other side, which is the product, you realize that they are not what? They are not equal. So you will try as much as possible to see how you can do what? You can balance the whole thing. How the number of atoms at this side, how is it going to be the same at the other side? So like now, take for example, the aluminium here is 2 and at the product here, the aluminium here is 1. So the first thing I'm going to do now is I'm going to add 2 here now. So this will change the number of atoms here, the number of aluminium atom here to what? To 2. Then I cancel out this. So these 2 has affected this aluminium. Has affected the bromine atom here to be what? To be 6. Then of course, here I have 2. Here I have 6. That means that I'm going to change this to 6 atoms. Then when you look at the other side here, you're having how many? You're having just 2 instead of what? Instead of 6. So what I'm going to do now is that I'm going to add another 3 here. So these 3 multiplied by these 2 will change this and it will result to what? To 6 atoms of bromine atom. So automatically the number of bromine atom at the left hand side of the chemical reaction is now the same at the product side. So the next one of call is how many sulfur do I have? How many sulfur do I have here? I'm having 3 here. And how many sulfur do I have here? It's still very much balanced. So it's still very okay. I'm having 3. I'm having 1 sulfur here, but at the other side here, I'm having 3. So let me put 3 here. So this sulfur will change to what? From 1 to 3. Will change from 1 to 3. So of course, the sulfur at the reactant side is now equal to that of the sulfur at the other side. So the next one of call is calcium. How many calcium do I have here now? I am having 3 atoms of calcium here. So this one will be changed. I'm also having at the other side. So this one will be changed. So when you look at it, what is left is that of oxygen. Here at the reactant, the number of oxygen here is 12. And at the other side, the number of sulfur, oxygen rather, is 4. So from what I've written here, this 3 multiplied by this 4, that is what it has changed to what? To 12. So automatically now, if you look at it categorically, you realize that the number of aluminium is also equal to this one due to all other elements involved here. So by and large, the equation is now balanced. You see this another thing is that when you look at it, you have AQ here. That means that this particular substance is in aqueous state. Why that of calcium 2-bromide is also in aqueous state. Then calcium tetraisosulfate 6 is in solid state. That is why we denote it with X. Then the other one, which is aluminum bromide, is also in aqueous state. So by and large, the equation is balanced. Thank you.